Welcome back. Section 10.5 Conic Sections. Conic sections or conics are obtained as intersections of a double cone with a plane. So here is a double cone and that's a plane. When you intersect it in this fashion, you get a figure. That figure here in this case is an ellipse. Now suppose I move my plane in a certain fashion. It's parallel to the oblique side of the cone. Then I get an infinitely long arc. That's your parabola. Now I turn it some more, the plane, I turn it some more and is perpendicular to the axis of my cone. Then I get what is called hyperbola. There are two curves together, they form what is called hyperbola. So we want to understand these conic sections. This is hyperbola, this is parabola, and this is an ellipse. First, parabola. A parabola is the set of points in a plane that are equidistant from a fixed point F and a fixed line L. The fixed point F is called the focus and the fixed line is called the directrix. So this is your directrix, this is your fixed point. So hold these two in place, that is keep the focus there, keep the line there. Look for all points on the plane which have the same distance from F as from the line. You see, distance from a line is the perpendicular distance. So here is a point. It has this distance which is equal to this distance. Yeah. Likewise, it turns out you will come across a curve. This point has the same distance here as it is with the line L. So what you get is a curve. That curve is called parabola. The fixed point F is called focus and the fixed line L is called the directrix. Suppose the focus F is on the y-axis. Say F is the point 0P and the directrix is parallel to x-axis. Alright, so directrix is parallel to the x-axis. So if that's my point 0P, my line is at 0 negative P, that is y equals negative P. That's my x-axis right in the middle. So here is a point that has the same distance from the focus as it has from the line. So origin is on my curve. And you keep looking for points which have the same distance from the point focus as from the line. So you have your familiar parabola. Alright, so let's take this point P. This point P, let's call it XY. Let it be a point on the parabola. Then by the definition, its distance from the directrix L and the focus F are equal. That is, d of P to F is equal d of P to L. Alright. Distance of the point to L. If this point is xy, this point was the distance, is the vertical distance. The vertical distance is the difference in y coordinates. Y coordinate for P is y. Y coordinate of L is negative P. You see? So difference between these two is y plus p, y minus p, y plus p. So absolute value. And on the left, we are simply using the distance formula. P is xy, f is 0p. So the distance between xy and 0p, x minus 0 quantity squared and y minus p quantity squared, add them both, take the square root. So that gives you your starting equation. Now, square both sides. I get x squared plus y minus p quantity squared equals y plus p quantity squared. Open the squares, complete squares. X squared plus y squared minus 2yp plus p squared. That was the complete square formula. Here, y squared plus 2yp plus p squared. Now, x squared minus 2yp survives here because y squared and p squared can be cancelled. Right hand side only 2yp survives. Move this over, you get x squared equals 4yp. So that's your equation of the ellipse, of the parabola. Equivalently, you may divide both sides by 4p and you get y equals x squared over 4p. Now this is something we are familiar with, degree 2, quadratic. You understand? So x squared equals 4yp is equivalent to y equals x squared over 4p. Now, basically the same argument give you the following situations. If your p is greater than 0, your focus is at 0p and the directrix is below the x-axis, y equals negative p. This is the case we just studied. Here the equation is x squared equals 4py. On the other hand, if p is negative, your focus is below the x-axis, directrix is above the x-axis. Y equals negative p is above the x-axis. Now here is a parabola which opens down. So this happens when p is less than 0. Okay. So wherever is the focus, your parabola opens in that direction. So in both the cases, x squared equals 4py is the equation of the parabola. This is when your focus is on the y-axis, either above or below. Now what happens if your focus is on the x-axis? So P0, if when P is positive, your focus is on the right. So the parabola will be opening right. Directrix will be behind the y-axis. If the focus is on the left, parabola opens to the left. Directrix is behind. In either case, the equation is y squared equals 4px. Alright. So here is an example. Find the focus and directrix of the parabola x squared plus 12y equals 0. X squared plus 12y equals 0 is same as saying x squared is negative 12y. So x squared equals 4py. That's your equation. X squared equals 4py is the equation. In other words, 4p is negative 12. P is negative 3. So notice x squared plus 12y. So x squared tells me that my parabola will either open up or open down. P equals negative 3 tells me my parabola is going to open down. Focus is 0, negative 3. Directrix is above, that is the line y equals 3. Next video, we will start on ellipses.